Good day, everyone, and welcome to today's webinar with Security Boulevard. I'm very happy to be with you. We're excited that you are here too. So let's move on to our topic, API security, everything you need to know to protect your APIs. It's my distinct pleasure to introduce our two speakers today. First, we have Aaron Lieberman. Aaron is Cloud Practice Manager and Architect with Big Compass. And we have Dan Gordon, who is Director of Technical Evangelism with Traceable AI. I'm going to turn it over to Dan and let him take it away.
Great. Thank you, Mitch. Welcome, everyone. Very excited to be here with our partners, Big Compass and Aaron Lieberman. Let's take a quick look at the agenda. We could go to that. So we're going to cover these subjects. Take a quick look. You can see there's time for Q&A at the bottom. I am going to cover Traceable Defense AI a little bit at the end to kind of give you a demo, show you how we do what we're going to be talking about in this webinar. And I wanted to mention that all of that we're going to cover is an excerpt or coming out of this great book that Aaron wrote, Practical Guide to API Security. And stay tuned for more information about getting access to that. With that, I will hand it over to Aaron.
Okay, thank you, Dan. Well, just quick introductions about me and about Big Compass and why it makes sense for Big Compass to partner with Traceable and things like that. So I am the Cloud Practice Manager and an Architect at Big Compass, as Mitch mentioned. And I'm an API security practitioner, architect, enthusiast, developer, API owner. I've played all of the roles of APIs in the past, and it's a topic that I'm very passionate about. And so passionate that I ended up writing this ebook on. And my whole goal for creating this ebook was to make API security more available to the public and lower the barrier to entry for anyone, any organization, any person within any organization to be able to effectively protect your APIs. And so I wanted to create this sort of practical guide to API security. So go check out the ebook. It's on Traceable's website, it's on Big Compass's website, and feel free to reach out to Dan or myself for more information. And the ebook will take you through a nice deep dive of some of the stuff that we're talking about here today. I also lead a couple meetups and love connecting with the community as well as connecting with you. So feel free to reach out to me on LinkedIn and get connected. And Big Compass, we are partners with a variety of different technologies that help us in our focus, which is integrations. So we partner with technologies like MuleSoft and AWS and Confluent and Salesforce and Boomi. And these are kind of the technologies that surround this integration space, some of the best in breed. And we focus on integrations. And a lot of what that means is moving data from one location to another. And also a lot of what that means is exposing data via APIs or enabling functionality via APIs. So we're implementing APIs with every single one of our clients today. And we deal with APIs all the time, which is exactly why it makes sense for us to team up with Traceable, because Traceable comes in as our API security expert friends. And we're on the front lines developing APIs and designing APIs and implementing APIs for our customers. And we focus on building connections. We build connections, literally between systems and applications in the integrations we create. And even more importantly, we build connections between people. And exactly what I was saying before, and leading some of these meetups and speaking at meetups and connecting with all of you, would love to do so to create more great connections. So let's talk about API landscape, something that I really like to see this graph that's on here on the page. If you look back to just a few years ago, you saw less than 1 million collections in Postman. And if you're not familiar with Postman, Postman is like the de facto way to make API requests these days. Test your APIs to run different requests on various different APIs. Lots and lots of people are using Postman. They produce these really great reports in the last year or so on the growth of APIs. And so there weren't even a million APIs in circulation on Postman just a few years ago. And there has been absolutely staggering growth over these last few years, the exponential type growth pattern that we've seen in the growth of APIs. And I would say that it's probably even more staggering than what Postman can report, because there's a lot of people out there that can't use Postman or won't use Postman or don't use Postman. And so, I think this is just a trend of the overall industry. And I truly believe that most, if not all, value will be delivered through APIs in one way or another very soon. So soak in these numbers, again, just absolutely staggering numbers. There's been 4.7 billion requests that Postman has tallied in 2019. And there's almost 500 million per month and 13 million per day. That boils down to 150 requests per second just going through Postman. You can imagine what that, if we're to boil the entire ocean, what that is in the entire industry. So this all makes sense because companies love APIs for spurring digital transformation initiatives. APIs allow for reuse and speed of development and so many other great benefits. But guess who's equally as excited about the growth of APIs? Well, hackers are. And that's a little bit of what we're here to talk about today. So right along with this exponential growth of APIs, we're seeing the number of API attacks directly correlated to the growth in APIs. And again, that makes complete sense. As you develop APIs, the downside to developing an API is you are increasing your attack surface. Many times your APIs access your data or access, mission critical systems in your business. And hackers then, they love that. They can then exploit those opportunities by exposing APIs and increasing your attack surface. So there was over half of organizations had 10 to 55 attacks per month last year. Again, soak that in. And 91%, almost all organizations experienced some API security incident last year. Again, absolutely staggering. But I'm not surprised because hackers are basically, they don't need eyes on glass to be able to launch these attacks. They're launching these automated attacks using machine learning and artificial intelligence and allowing bots to probe the internet and launch these attacks without the hackers even knowing. And so even the top companies in the world are being affected by this phenomenon. You get the Facebooks and the Googles of the world, who we widely regard as some of the top tech companies in the world, are being affected by these API attacks. 50 million Facebook accounts were breached by an access token harvesting attack. And that's really scary because if you're stealing access tokens, then and you're flying under the radar of what traditional API security can provide you, well, then you probably have free reign on that API. And T-Mobile, I really like this headline. It says leaky API. Well, it's a little bit funny, and I laugh because leaky API. Well, that's something that might have slipped through QA. Might have been deployed to production, and nobody knew about it. It was leaky. It was leaking information that they didn't want to expose to the public. And then USPS. I also like this headline: API snafu. Who hasn't had an API snafu here, right? I've had an API snafu. Hopefully it doesn't lead to 60 million users affected in this API snafu. But again, these top companies of the world being affected by this phenomenon of hackers getting smarter and attacking these APIs in an automated fashion. And part of that is due to API visibility. So API visibility plays a key role in API security. So let's talk about that just a little bit more now. So there's this massive growth in APIs. We already established that. But you would be surprised at the number of APIs that get deployed without documentation. It still happens today. It still happens even with these great tools like MuleSoft and like AWS and like some of the other technologies that I mentioned at the beginning of the presentation. Even with these great tools that make it so easy to document and inventory your APIs, APIs get deployed all of the time without being documented. And so there's entire organizations, like MuleSoft, that base their model off of creating layers of APIs to abstract experience from business logic, from back-end data. And that model completely makes sense. As you can kind of see on the screen here, this is actually a great architecture for APIs. And it leads to great microservices-based architectures. What it also leads to is a growing inventory of APIs. And so you need to be able to manage that inventory of APIs. And it's kind of interesting. I've heard this slogan emerge. There's an API for that. And I love that slogan. I love connecting to the modern SaaS type of systems where there is an API for that, because it's so easy to connect to these different types of SaaS systems where there's an API fronting that data. And you're almost turned off when there's not an API for a system that you're connecting to. So the message here is, with all these APIs in existence, it is absolutely crucial to maintain a good inventory of your APIs in order to protect them. And so these tools like Swagger and RAML and Open API Spec make inventory management that much easier. And a great approach to inventory management, because we all know developers love to document. Not developers do not love to document. Developers love to develop and do what they're good at. So a great approach to solving this is incorporate documentation and your inventory right up front in your service development lifecycle. So what I really love to do is I love to document APIs, in RAML, OAuth, spec, and then you get an API definition documented as the very first step in your project. And then you can iterate on that API's definition. And then only after you've defined that API's definition, you can move that API to a development phase and build the life behind that API. And what that does is that allows you to use, a good list or inventory tool to be able to have a nice documentation for your APIs. And you can't protect what you don't know about. So if you had a rogue API out there in your ecosystem, you might not even know of its existence. So how do you begin to protect that? So if you leave this presentation with nothing else, the first step to protecting your APIs is to inventory your APIs, because you can't protect what you don't know about. So try to incorporate that into your service development lifecycle, as a part of DevOps, maybe even, and see these are some of the good practices that these tools that I've mentioned make so easy today. And microservices also plays a role. So we've discussed the API's visibility and how that relates to security. And now it's time to talk more about microservices, because that plays a big role in API security as well. And with the emergence of microservices over the last few years, you might ask yourself, how do you make sure that your entire distributed microservices footprint is protected when you're crossing these boundaries of microservices? So very similar to the API growth landscape, the microservices growth rate is pretty staggering as well. It's not as staggering as APIs, but more and more people are moving to this microservices architecture. And it's great. It's great because it allows for scaling opportunities, for reliability, for decoupling of application components, speed and efficiency. You get DevOps efficiencies and cost efficiencies if you're breaking up monoliths. So lots of great benefits that you can achieve from microservices. And you can see, I really like the table at the bottom of this slide, that the projected growth for microservices is going to about triple in just a matter of about 5 years. So that tells you that this is a trend that's here to stay, just like APIs. And so there's this trend to break up your monolithic applications into different microservices, because people believe in this approach, in this microservices first approach. And what used to occur is we used to create these giant monolithic applications, and you throw a lot of horsepower at these monolithic applications, and parts of that were actually nice. I'll be the first to admit, it was easy to maintain the system. It was easy to deploy to one location. It was easy to govern that single application or that single system. Inventory was very easy because you could count it on one finger. There's just one. You can log from one location to one location very easily. And now when you break up that monolith, though, you might break that up into tens, maybe even hundreds of different microservices, which can all now run in parallel. So your mindset is even shifting a little bit. And that's a double-edged sword. So on one side, it gives you that scale and that reliability that I just talked about. And on the other, it's a little bit harder to govern. It's a little bit more difficult now to run all of your microservices potentially in parallel. And you have to change your mindset. It's a little bit more difficult to log to one location due to the distributed and succinct nature of these microservices. And so if you have all these microservices floating out there in your ecosystem, that can work really well for you. And I would even recommend it. There's no reason not to do that, but you have to have a plan in place to govern them effectively, number one. And if you lose track of requests across your microservices boundaries, because you have all these boundaries that you're crossing now, well, you can't protect your system. You need to know what's happening in your system across these boundaries to be able to effectively secure your system. So it's all about the right planning and the right architecture. So what is that right architecture? There's plenty of different, quote unquote, right architectures out there. But typically your APIs are decoupled from your business logic, and requests are traced across boundaries using proper logging techniques. And there's many more best practices out there. I even wrote a serverless ebook on the subject because I love this subject. So feel free to check out the serverless ebook as well. And I like to think of this in terms of 3 ilities is what I call it. Visibility, we just talked about visibility. Traceability, which we'll discuss a bit more here in a second, and supportability. And if you're logging across all of your different microservices in terms of enhancing visibility, traceability, and supportability, you'll be on the right path. And at Big Compass, we've helped almost every single one of our clients with this very problem. Because once you break up these monoliths into a bunch of different microservices, well, it's hard, it's difficult to log and create these logging standards across all of these different microservices. It's not an easy feat to accomplish. So it's something you have to plan for and implement this logging, these best practices in logging techniques. And you have to have traceability across your microservices. And that's the key here. If you lose a transaction and you can't find a transaction across your microservices, well, then you can't protect what's happening in your system because you might have blind spots in your system. So the link across these microservices, so the ability to trace across these microservices, is step number 2 in protecting your APIs. And so, compounding on top of these factors, there's this modern architecture of, APIs decoupled from the business logic and these microservices emerging. And not to mention, hackers are getting smarter. So the cost of a breach these days is outrageously expensive. And what compounds that is the time to identify and contain a breach, an API breach, is absolutely flabbergasting. Both Facebook and Google took over 1.5 years to detect their API breach. Can you imagine that? Over 1.5 years, they were being exploited. And as that 1.5 years, goes on, as time goes on, their breach becomes more and more intrusive. You might even lead to API takeover over that time if a hacker can understand your API well enough. And so it gets more and more expensive over time, right? So the ability to contain a breach very quickly is so important. And you're stealing so many records over that amount of time that you want to be able to contain the number of records that hackers are stealing. And so API attack detection is extremely difficult and a true needle in a haystack. I don't think anyone would say that this is easy. Even the technologies like Traceable, building entire technologies to help you detect these needles in a haystack. And API breaches can take months or years to detect because there's a very high volume of traffic across APIs. You have a high velocity of connections, and the diversity of traffic running across your APIs is something like I've never seen before. It only gets more diverse as time goes on. And assigning API ownership is very crucial as well. API ownership is not always clear, and if an incident were to happen, having an API owner is very important so that you can escalate appropriately and deal with breaches appropriately if that were to come down to it. And so now to compound these factors, even in the OWASP API security top 10, the traditional gateway security and WAF and RASP protection don't protect some of these known advanced attacks. So even in that API security top 10, some of the things that we rely on today, like a WAF, might not protect against some of these known API attacks. So these more advanced API attacks are actually reducing the effectiveness of our traditional API security measures because hackers are getting smarter. Hackers are launching advanced attacks using machine learning and artificial intelligence, and even hackers themselves might not even know what their programs are going to do next. That's the scary part. OWASP API top 10 identifies the known attacks, but what's really scary is the unknown out there. And we need to be able to enhance our security on APIs to protect against what we know about as well as what we don't know about. Because these advanced attacks are unpredictable. And even if your APIs are behind a firewall or in a DMZ, we're also seeing an emergence of insider threats as well. you're never safe, even from somebody within your own organization. And hackers know this, and we need to be able to determine with the proper visibility and traceability how to protect our APIs and anomalous behavior on our APIs. So I'm going to break up the talk track just a little bit here with one more polling question. And Mitch, we're ready for polling question number 2, which is, what kind of API attacks have you experienced? And this will be, you can select multiple answers here if you've been through many different API attacks. Or maybe you don't know, which is also very common.
All right, we're in the wild here getting responses, so join in from the audience. And as with last time, option H is other. So please pop your other response into chat so we get an idea of what other might be. And responses are rolling in. What kind of API attacks have you experienced? I liked your part of, you may not know. I know we've been attacked, but I'm not sure what it was.
Yep. Very common. And we're seeing that as I'm looking at the live results as being the number 1 answer so far.
Are we counting the I haven't been through an API attack as I don't, or I don't know, maybe as well?
Well, if
or
you
I don't know,
you
I
don't know,
yet,
right?
Dan, you don't know
Yeah,
what you
it could
don't
be
know.
that.
Is that what that is?
Yeah, exactly.
Those might have overlap.
Good. Well, we've got, I think, a pretty good
Good.
cross-section here. I'm going to go ahead and close the poll.
It's very interesting.
Yeah, if Aaron, you want to walk through the results there?
Yes. So what we're seeing, number 1 answer is I don't know. And I'm not surprised, actually. It's hard to detect these API attacks like I just talked about. And without the proper attack detection techniques, you might not know if you're being attacked or not. And then number 2 is no, I haven't been through an API attack. That was actually at 26%. And I am surprised by that one, that over 1/4 of people are claiming that they haven't been through an API attack, that's great. Based on my previous slide, 91% of organizations had been through an API attack. So that's great, proving our numbers wrong potentially. And then we see brute force login attacks. I see those all the time coming in at number 3. Dan, anything else you wanted to point out here that was interesting?
No, I think you got, well, actually, I missed the authorization exploit. Maybe that's just by what it's called or knowing about more details about it, is been listed as one of the top authorization general kind of API attacks. That shows kind of low in our poll, so it's interesting.
Yeah.
Real world versus the stats, right? So.
Yeah, throw in one other comment. It is kind of well dispersed across all the different kinds of attacks options. So it wasn't like it was all dominated by brute force or something else. So good mix, which is, I don't know, good or bad, but tells you the variety of what's happening, right?
Exactly. Okay, well, I'm going to move on. Thank you again for your participation. And next, we're going to talk about business roles and how those play a role. So this is the age-old people problem. People are imperfect, and people have to come together to protect APIs. And that's, again, where we can start and we can help each other. So it's too often that, one person in one part of a business, like an Infosec professional, might be very knowledgeable about the subject of protecting APIs and API security, but an API developer who's tasked with developing and protecting the API might not know of that person and might not necessarily have the same skills as that person in the Infosec group. And, so I would say, if we just look at this as a people problem as well, and bridging these gaps, and I think enterprise architects can help with that. Enterprise architects can come in and bridge that communication gap and introduce people and do knowledge transfer across these groups, where API developers can probably enhance their skills with API security. Infosec can work with API security professionals. Enterprise architects can come up with an aligned plan across all of these roles. And then that also enables operations and support to put together a long-term plan if APIs were to be breached. And so I really like this Venn diagram, because in the absence of any one of these roles, things start to fall apart, and you can see what each role might be responsible for. And what I like to highlight here is that there's almost a perfect dichotomy between API developers and Infosec. Infosec is tasked with protecting data, and API developers are tasked with exposing data. And so now you have to try to bridge that gap and find a perfect balance between exposing the data in a protected, secure way. And I think enterprise architects, I think, can help bridge that gap where everyone's common goal is securing APIs and secure data access. So final part of my presentation here is finally, how do you actually, with all of those factors in mind, how do you actually protect your APIs with all of those factors sort of pushing against you and giving you those headwinds? Well, it's a layered API security approach. And step number one is inventory your APIs. Again, I want to reiterate that. And then you think about, the people problem, the visibility and traceability that I talked about. But then after that, you look at your gateway security. And that would be step number one after everything that I just talked about. And a lot of tools make this relatively easy to implement these days. The tools like MuleSoft and AWS and Azure and Boomi, they have these built-in gateway security mechanisms where you can fairly quickly implement gateway security mechanisms like OAuth 2.0 and rate limiting and IP whitelisting and client ID enforcement and so on. And this helps protect against your brute force type of attacks or your login attempts, your failed login attempts. So this will start to single out those brute force attacks and throw them out at the API gateway layer. It does not protect against SQL injection type of attacks, OWASP API top 10 type of attacks, or other advanced attacks. So you have to think about those more advanced attacks now, which brings us to layer number two. Layer number two, and even step number two to helping to protect your APIs, is a WAF or RASP. And what you can see here is WAF or RASP helps protect now against your OWASP top 10 attacks, like SQL injection and distributed denial of service and cross-site scripting. So if we're looking at the different types of attack vectors, your brute force login attack will actually get through your WAF and RASP, and they're not meant for that. That's your API gateway security. Your API gateway security will still block your brute force login attacks. And then if you put a WAF or RASP in line with your API gateway, you can then start to block those OWASP top 10 type of attacks like SQL injection. But what that's still leaving you vulnerable to is the advanced attacks and even some of the OWASP API top 10 attacks. And those are the most sophisticated attacks, and those are the unknowns that we don't know what will be coming next. And that leads us to step number three, or layer number three, which is that last line of defense. And this is where it gets a little bit nuanced. So this last line of defense is a machine learning and artificial intelligence layer. And what this machine learning and artificial intelligence layer can do is model the behavior on your API and then start to detect anomalous deviations from the normal behavior of your API. And that way it can implement a zero trust strategy. So whether it's insider threat, advanced attack from a hacker, or something else, it will detect that this is not normal behavior on the API and then can reject those type of advanced attacks. The advanced attacks that I'm talking about is anything along the lines of stolen tokens like we saw with Facebook. If you get authenticated access, it's really hard to be able to detect those because you might be flying under the radar of what that API is trying to detect. The insider threats, stolen credentials, data exfiltration, those type of advanced attacks are very difficult to be able to detect. So now with these three layers in place and your machine learning and artificial intelligence security engine in line with your APIs, helping to protect your APIs and learning the behavior of your APIs, you can now protect against brute force login attacks at your API gateway layer. You can protect against SQL injection attacks at the WAF or even at the machine learning and artificial intelligence layer as well, which Dan will talk about. And you can detect those advanced attacks now as well, using that machine learning and artificial intelligence layer that detects deviations from the normal behavior on your APIs. And now this is a little bit of a different mindset. It's a new approach and new way of thinking. Previously we thought that WAF, RASP, and API gateway security could give us full protection, even NG-WAF. We thought that could give us full API protection, but we're still seeing these API breaches. And so now to be able to fight fire with fire, which is hackers using machine learning and artificial intelligence, we need to use machine learning and artificial intelligence so that we don't have eyes on glass, eyes on our computer, monitoring constantly for a needle in a haystack. And so I'm going to turn it over to Dan to talk about this new approach to application and API protection. So I'm going to stop sharing my screen, and Dan, take it away.
All right. Thank you very much. Really great stuff, Aaron, and great book that covers all of this in depth. We love working with Aaron and the team at Big Compass, and that we think the same way about API security, application security, and we've kind of captured that in a tool that we think helps with all of those advanced features, as well as the more standard features or challenges that we see. We call it Defense AI. Now, what you're seeing on screen is kind of a architecture, granted, but I want to talk about how Defense AI enables the ability for you to control your application security and your API security posture. We do that through visibility, protection, and what we call resolution. Again, alignment with what Aaron just talked about. But let's start at the bottom here at distributed tracing. And I'm going to start there because that is the foundation of Defense AI, which is we are doing distributed tracing, meaning we have the potential to have sensors at all stacks or at all layers of the stack, including the API gateway, in your Kubernetes cluster, at the application layer, at your perimeter. And that enables us to feed a lot of data that's about the transactions that are happening from the inside of the app, from the outside of the app, across all of the microservices, and trace those and track those and feed all that data into our Trace AI platform, which is their security-focused AI, taking all that data in, working with the trace information, and figuring out what is the base state. From that, we can detect anomalies and offer visibility, protection, resolution. Visibility is the ability to see across everything you have and in depth as well. Protection, as we mentioned, is about what traditional WAFs and RAFs used to do, but it is also about protecting against those API attacks and those more advanced business logic attacks that Aaron talked about. And then resolution is about how do you bring all the teams together? How do you give them the information to not just detect and block problems temporarily, but to actually solve problems so they don't keep coming up, keep being vulnerabilities. So if we go to the next slide, what we'll do is these slides are here. They're screenshots. It has some data about it. I'm going to cover these in the demo. We'll scoot across these, but they're in the deck in case you want to look at it offline. But the visibility comes in two parts. Actually, I think what we'll do is we'll just cut to the demo because I'm going to talk about all these pieces. But again, these slides are here for you with a little bit of detail. What we're going to do is there is a dashboard that shows you kind of your overall security posture across your application landscape. It shows you your active threats. You're not usually going to have 820. This is a demo system, and everybody adds their own stuff. But we're going to start with that visibility part, which is over here in application flow. And I'm working with resolution here, so let's make sure we can see enough. Your microservices, Aaron started with that. Right, with your APIs and your microservices, and how do you see all the different layers? So we're going to start and look at your microservices and your services and how they connect. Again, this is all coming from trace data. It's discovered. It's not put in or input by anyone specifically. It's not based off of specs which your developers or your architects have to update in order for the system to know how everything connects. This is live, real-time data, looking at everything from your edge, your north-south traffic going in to your east-west traffic and how things are connecting and communicating internally, all the way down and back into the data sources. And all of this information is available and is in the system. And we look at it, and the AI looks at it to be able to do normalizing and figuring out what is the base state. and then also go beyond and understand when there's anomalies. We also have your typical observability, regular observability type data like latency and error percent, your call rate, etc. But there's also that next level, right? And we'll jump into that next level by hopping into this trace shop service. This gets us down into that API level or into the service level. And this lets us see, okay, now we're talking APIs, right? So we do, again, have observability data and security data for the service itself, but we've also got now a discovered and constantly updated list of the API endpoints. Each one of those, what call type, whether or not it has sensitive data, helping you guard your PII, whether or not it has authenticated properly or not. And let's go ahead and pop into one of those. We'll look at checkout here. That's usually pretty active. Again, observability data there, but we've also got this piece, which we call DNA. This is the definition reverse engineered from watching the traffic, understanding the application, looking at everything that's going on, so that we can give you this view. This is better than a Swagger/Open API description or spec because this is actual. This is real. What's going across the wire based on that, and from that we're able to pull information out like, is it talking externally? Does it have requests that contains parameters, which means it could be subject to an injection attack, right? So we look at different pieces of information, things like, are there lots of different IPs that are calling this particular endpoint, or is it just a few? A few would be safer. We also understand the kind of user roles that call it, geographic information, which I'm not representing here, all the way down to the parameter information. So for example, there's a credit card parameter on this particular one. It is part of the request, and we see that it has PII. So we understand information about the PII, and not depicted here, but even to the level of what is the usual type of information that gets sent into there. All of that information rolls up into what we call a risk score, which allows you to understand not only your entire API inventory, again, generated from, without feeding in specs and without updating docs, but from watching and understanding and learning and reverse engineering. But it also enables you to understand your risk level for each of those endpoints in the inventory. And then that's across all of your APIs, across all of your services. Now, we also have the traces that this particular API endpoint has been involved in. So we do this all by sequencing API calls. And we do that, sequence API calls so that we can build up a comprehensive baseline across your entire application landscape. And that enables us to identify threat actors, right? We don't work on the basis of IP, but understanding the calls and looking at all the data together, we're able to understand who are the threat actors or the users who are doing things that we're not so sure are the good things that they should be doing. So we can search through, for example, there's our guy that does a lot of questionable stuff for users. And then for that threat actor or user, you can see everything that they have done across time, across IP addresses, no matter where they're coming in from, across attacks, across systems, across services. And so this is all pulled together into what we look at as a storyline on this user and what threats they might be doing. So we can see that this particular user has done some SQL injection attacks, which were identified, several other things, some injection, XML injection, some cross-site scripting, et cetera, et cetera, et cetera. Lots of stuff here that we can explore and understand, okay, this person, not sure we want them in our systems. Let's take a look even deeper. Here we have a particular mass assignment attack. And what they did here is, our system's identifying in the request body was total price, which we usually don't see coming into a request. So this is the AI intelligence understanding what should be happening versus what is happening, right? And if I dig deeper, I have all the data there, request, response, and attributes. I can even see in the body that they actually set that price and they set it to 0. Not a usual behavior for our users. This user is doing it, so it got flagged. Now, We can see that across all of these. We can dig into any one of these. And let's say that we're looking at a particular thing, like here we have a BOLA or an object authorization attack. Let's say I want to dig deeper. I want to understand more, do some maybe reconnaissance or some forensics. I can go to that session, and this brings us then to our Explorer. Now our Explorer is sitting on top of this huge data lake of information we have about all the transactions across your application landscape, across all your APIs, across your API endpoints. And this one is particularly searching on this session. And I'm going to zoom out a little bit here so we can see. And we can see everything that from that attack point that this user has done, whether it's good or bad. Again, all this data helps build up our understanding of user behavior and attack behavior. But this allows us to also investigate and go deeper and see the traces underneath. And we can even further refine that search by many, many different parameters that we hold, including digging into the request body, for example, and searching for certain information, seeing what was sent, what was the attack that was done. So a lot of great stuff there on being able to do a deeper dive and understanding. This is something that developers, you might use to dig in and understand where there's a vulnerability or how a vulnerability or calls to your endpoints have led up to a vulnerability, how things are being attacked. AppSec can use this to understand, again, forensics of an attack. And so we have this particular user that we've based that off of, but let's ask ourselves, did this user work on their own? Right? Oftentimes we have multiple teams that are working a similar attack at different angles. That's a possibility. So how do I understand not just the detonation point, which is this attack that happened, but the blast radius, right? How much more is happening that's beyond this one attack that I'm looking at? For that, we have user behavior, and we can look at the behavior of different calls to different endpoints and get a sense of, I'm going to just pull this out a little bit here, and get a sense of for a particular type of attack, are there other actors? And what this does is this takes a look at the baseline, which is down here, and then shows information like, okay, well, here was the attack point. Here's the set of calls that they made up to that attack point. And we can see again, okay, well, this one is very popular. So I might surmise from this that there's quite a few folks that are making this attack. They might be coordinated, and our attacker is likely in there as well. And so stepping back, this is giving you a view overall from the overall visibility of your APIs and your information that you have for all of your application communications, all your API calls. It's giving you access deeper into the API details and inventory, plus all of the observability information from a security perspective around those APIs, and the ability to look from user attribution standpoint, because we work from a user attribution standpoint, to what a user or what a threat actor might be doing and where they are touching the system and abusing APIs, to being able to come back out to that last piece. And I love that you have that, Aaron, in there about the roles, because security is not just AppSec finding problems, and it's not just devs testing for problems or just architects making sure they're architecting around potential problems. It's that combination, like you said, of everybody having the views together, being able to see the data so that they can work together and to research, troubleshoot, dig in, and find those problems. Moving this information over to the dev side, where like in pre-production, for example, you can understand the risks that you're taking with APIs or that you're creating in APIs as you make changes to them. Looking at attacks that have happened and being able to use that data to make smarter choices. In production, the protection piece around, again, you can throw out your WAF, your NG-WAF, your RASP. This will do all of those blockings for you, plus the API security, plus the business logic attacks, and then on into helping everyone work together to actually resolve those problems so that they're not continually being problems. So that is kind of the story there.
Thank you. Thank you, everyone, for joining us today. We appreciate you spending an hour of your time with us. We hope that we've used it well. We've honored you to spend it here. We look forward to next time that we see you. Take care, everybody.